We've all been hearing it, right? This constant buzz. AI tools are going to completely revolutionize software development,
Right.
make every engineer faster, more efficient, almost overnight.
Yeah, it's a really powerful narrative. You see the demos, the headlines, and it seems inevitable. But what if, just maybe, for really experienced pros working on those big, messy, real-world projects, the opposite was actually happening?
What if AI actually slowed them down?
Well, that's not just a what if. That's the really fascinating and honestly kind of shocking finding from the study we're digging into today. It's called Measuring the Impact of Early 2025 AI on Experienced Open Source Developer Productivity.
Right. This is the work by Joel Becker, Nate Rush, Beth Barnes, and David Rain from MTR Model Evaluation and Threat Research.
Exactly. And they ran this rigorous randomized controlled trial to see what really happens when you put these tools in the hands of seasoned developers on their actual projects.
So our mission for this deep dive is basically to unpack what they found, because they really tried to go beyond those clean lab benchmarks, measure the real impact, bridge that gap between the lab and, well, the messy reality.
Okay, so for those of you maybe short on time, here's the quick version, the key takeaways in about a minute.
Go for it.
All right, so this deep dive is all about an RCT, a randomized controlled trial. They had 16 very experienced open source developers working on real tasks and projects they knew inside out, these large, mature code bases.
And they were using the latest AI tools from early 2025, primarily Cursor Pro with Claude 3.5 or 3.7 Sonnet. Pretty cutting-edge stuff at the time.
Right, but here's the kicker, the real head turner. The study found that allowing these AI tools actually increased the time it took to complete tasks by 19% on average.
19% slower. Let that sink in. Developers were slower using the AI.
Yeah, and this flew in the face of all the expectations. The developers themselves, they predicted a 24% speed up. And experts in economics and machine learning, they were even more optimistic, forecasting like a 38-39% speed up.
So a massive disconnect between prediction and reality. Why, though? Was the experiment flawed?
That's what you might think, but the researchers were really careful. They ruled out the obvious stuff. It seems to boil down to a mix of things. One, the developers were already super familiar with their code. Two, these repositories were huge and complex. And three, frankly, the AI just wasn't reliable enough and lacked that crucial implicit understanding of the code base.
Okay, so this finding doesn't just tweak the narrative, it kind of flips it on its head for this specific context, doesn't it? It really highlights why these real-world field experiments are so important, not just lab tests. A genuine aha moment, especially if you're building or deploying these AI systems.
Absolutely, it makes you pause and think.
So given those surprising results, why this study? Why was it so important? You mentioned this inferential gap. Can you elaborate on that?
Sure. Look, we've all seen impressive AI results on benchmarks, right? Studies showing, a 56% speed up on specific coding tasks or 21% on other things. But the problem is, those often use what the paper calls synthetic tasks.
Synthetic tasks, meaning like coding challenges, not real work.
Pretty much. They're often self-contained. You don't need deep background knowledge of a huge existing project. They're designed to be easy to evaluate algorithmically, which isn't always how real software value works.
Right, it's like testing a race car driver on a go-kart track. It tells you something, but maybe not how they'll handle Le Mans.
That's a great analogy. And sometimes these tasks might even be things the AI models were heavily trained on, giving them a sort of home field advantage.
Okay, so synthetic tasks are one issue. What about other attempts to measure this in the wild? You mentioned they also had limitations.
Yeah, they did. Some field experiments looked at things like lines of code generated, or the number of tasks a developer completed.
Which sound like reasonable metrics at first glance.
They do, but the paper makes a good point. AI could potentially game those metrics without actually improving true productivity. Think about it, an AI could generate really verbose code, boosting the line count without adding real value.
Or it could encourage breaking down one big task into lots of tiny ones, making the task's completed number look good, but not actually saving time overall.
Exactly. Inflated metrics, not necessarily real gains.
So how did this METR study get around those problems? What was their secret sauce?
Well, meticulous design, really. First, they used unfiltered, live, open source repository tasks. Real issues, bugs, features from the actual projects these developers worked on day to day. No artificial stuff.
Okay, real tasks, that's crucial. And they used a fixed outcome measure. What's that mean practically?
It means they decided exactly what they were measuring the time to complete a specific task before they randomly assigned whether the developer could use AI or not.
Ah, so you can't accidentally change the goalposts later, or let the AI influence which tasks get counted or how big they seem.
Precisely. It keeps the measurement clean and unbiased. And another really key difference was who they studied. Lots of earlier research hinted that AI helps junior devs more.
Right, the less experienced folks get a bigger boost.
But METR specifically recruited experienced engineers with years of expertise on these specific repositories. They wanted to see the impact on the people who supposedly needed the help least.
And they didn't just rely on self-reported times, did they? You mentioned rich data.
Oh yeah, they went all out. They collected 143 hours of screen recordings. And get this, manually labeled at roughly 10-second intervals. Super granular detail on what developers were actually doing.
Wow, that's dedication.
It is. Plus, they looked at source control stats, did developer interviews, surveys. They even got forecasts from experts beforehand about how much speed up they expected. Really comprehensive.
That level of detail is impressive. Okay, let's zoom in on the how. Who are these developers exactly, and what were these projects like?
So 16 software engineers. Generally, we're talking over a decade of experience in the industry. And critically, they weren't just random experienced devs, they were active contributors to the specific open source projects being studied.
So they knew the code base as well.
Extremely well. On average, 5 years working on that specific repository with something like 1,500 commits under their belt. These are the folks who really understand the nuances.
True experts on that code. How'd they find and convince them $150 an hour probably helped?
Yeah, compensation definitely helps ensure commitment. They recruited through professional networks, ML communities, and also by directly contacting prolific contributors on Meet or GitHub repositories.
Got it. And the repositories themselves, were they small, simple projects, easy for AI to digest?
Absolutely not. These were beasts, large, mature projects, average stats, 23,000 GitHub stars, about 1.1 million lines of code, often 10 years old or more.
Whoa. Okay, so complex, established systems.
Exactly. And with very high standards for contributions, rigorous code reviews, specific guidelines, the kind of real-world complexity AI often struggles with. Not simple, clean, greenfield projects started from scratch.
That context makes the task setup even more interesting. How did they handle assigning the actual work?
They took 246 real issues, actual bug reports, feature requests, work items straight from the issue trackers of these repositories.
Stuff the developers might have worked on anyway.
Pretty much. The average task took about 2 hours to complete based on developer estimates. And the critical part, as we mentioned, was defining these tasks before randomization. Then, like flipping a coin, each task was assigned to either the AI allowed group or the AI disallowed control group.
Okay, fair assignment. And when AI was allowed, what were they using? Was it super restrictive?
No, they gave developers agency. The main tool ended up being Cursor Pro. It's a VS Code fork, popular for its AI integrations, hooked up to Claude 3.5 or 3.7 Sonnet.
State-of-the-art models for early 2025.
Yep. But importantly, developers weren't forced to use it. They could choose other AI tools, or even choose not to use AI at all for a given task if they didn't think it would help.
So, real choice. Did they have experience with these tools?
Mixed bag. Most, 93%, had used LLMs before in some capacity, but only 44% had specifically used Cursor. So they provided some basic training just to get everyone comfortable with the interface.
All right, the stage is set. Meticulous setup, experienced devs, real tasks, complex projects. Now the results, because as you said, the headline finding just jumps out at you.
It really does.
Yeah.
To state it plainly again, allowing these advanced AI tools increased task completion time by 19% on average.
So in this setting, with these developers on these tasks, AI made them slower, not faster.
Slower.
Chloe.
Slower. And this wasn't just slightly off from expectations, it was the complete opposite. Remember those developer forecasts? They predicted a 24% reduction in time. And here's where the cognitive bias part gets really interesting. Even after the study, after they had personally experienced taking longer on tasks with AI, when asked to estimate the effect again, they still estimated a 20% time reduction.
No way, even after living it.
Even after living it. It shows how powerful our pre-existing beliefs about technology can be, right? They experienced a slowdown, but their mental model still said, AI makes me faster.
That's kind of mind-blowing. It really speaks to maybe wishful thinking or just the hype overriding personal experience. And it wasn't just them. The experts were way off too.
Way off. Economics experts predicted a 39% speed up. ML experts predicted 38%. If you look at figure 1 in the paper, we should link that it's visually striking. All these green bars showing predicted speedups, and then this one stark red bar showing the actual observed slowdown.
It's fascinating that the developers were actually pretty good at predicting how difficult a task would be, just not how helpful the AI would be for it. Their belief was just flipped.
Exactly. Their intuition about task complexity was fine, but their intuition about the tool's utility in that context was wrong.
So how are they spending their time differently when AI was allowed? Those screen recordings must have shown something interesting.
They really did. The analysis showed that when developers had AI available, they spent a smaller fraction of their time on what you might call core coding activities.
Like actually typing code or reading existing code, searching for stuff.
Exactly. Less active coding time, less time reading and searching.
Okay, so if they weren't doing as much of that, where did the time go?
It shifted towards AI-specific interactions. A decent chunk, about 9% of their total time in the AI condition, was spent just reviewing the AI's output, checking what it generated.
9% just reviewing.
Okay, plus time spent writing prompts, fiddling with the AI settings, and interestingly, about 4% of their time was just waiting for the AI to generate a response.
The latency factor. 4% waiting time.
Yeah, and maybe the most intriguing bit from the time analysis, they also spent, and I'm quoting here, a somewhat higher proportion of their time idle when AI was allowed.
Idle? Like just sitting there?
It seems so. Maybe thinking, maybe waiting, maybe just a different workflow rhythm induced by interacting with the AI. It wasn't just a simple swap of coding time for AI interaction time. It changed the whole dynamic, introducing more pauses.
Okay, this brings us to the absolute core question, the million-dollar question, really. Why? Why this slowdown? The study dug deep and identified 5 key factors. What's number 1?
The first big one is that over-optimism about AI usefulness we already touched on. This directly led to productivity loss because developers believed so strongly it would help, even when it wasn't.
They kept using it, right? It's like if a hammer isn't working well for a screw, you'd ideally switch to a screwdriver. But here, the belief was so strong, they kept trying to make the AI hammer work, even when it was counterproductive.
That's a good way to put it. They overused the tools because of that cognitive bias, thinking it must be helping, even against the evidence of their own stopwatch, effectively.
Okay, over-optimism. What's factor number 2?
Factor 2, high developer familiarity with the repositories. This is crucial. It raises the baseline of human performance so high that the AI struggled to add value.
Because these developers are already experts on this specific code.
Exactly. Years of experience, thousands of commits. They have this deep, ingrained knowledge. The study found AI was less helpful on tasks they already knew well, tasks with high prior exposure, or where they didn't need to look much up, stuff they could basically do from memory.
That makes sense. So the AI's potential value diminishes when the human is already operating at peak efficiency for that specific context. Did they find it useful for anything?
Yes. Anecdotally, developers mentioned it was more helpful for things they weren't familiar with. Maybe learning a new API used in the project, or figuring out some obscure GitHub configuration. This aligns with the idea that AI might help bridge knowledge gaps, benefiting less experienced people or experts tackling unfamiliar territory. But for their core, familiar work, not so much.
Got it. Familiarity raises the human bar. What's the third factor?
Third is the flip side. The large and complex repositories themselves actually limited the AI's performance.
The nature of the code base itself tripping up the AI.
Right. Developers explicitly noted that the LLMs just didn't perform as well in these huge, messy, decade-old code bases. We're talking 1.1 million lines of code on average.
What kind of problems did they see?
Things like the AI suggesting weird changes in other parts of the code completely unrelated to the task. Or it would struggle with larger refactoring tasks, saying it was too big, likely hitting context window limits. This meant developers spent extra time cleaning up AI messes or working around its limitations.
So the sheer scale and interconnectedness, the legacy aspect, was a major hurdle for the AI, unlike in simpler and newer projects. Okay, that leads naturally to number 4.
Number 4, low AI reliability. This was a really big one. Quantitatively, developers accepted less than 44% of the code generations proposed by Cursor.
Less than half. So more often than not, they looked at what the AI produced and said, nope, not using that.
Pretty much. That's a lot of wasted effort, both for the AI generating it and the human evaluating it.
And even when they did accept it, it wasn't smooth sailing.
Not at all. Remember that 9% of work time spent just reviewing and cleaning up AI code. That applies even to the accepted code. 75% of developers said they read every line of AI code, and over half, 56%, so they often need to make major changes to clean it up.
So even the good suggestions needed significant manual effort. It's not just plug and play. That overhead sounds like it could easily wipe out any speed gains.
It certainly seems like it did in this case. Which brings us to the fifth and final key factor identified by the study.
Okay, what's number 5?
Implicit repository context. This is about all the unwritten rules, the tribal knowledge. It both limits AI performance and boosts expert human performance.
The stuff that's not in the comments, not in the docs, but every experienced dev on the project just knows.
Precisely. The AI tools lacked this tacit code-based knowledge. Developers literally said the AI acted like a new contributor. It might put code in the wrong place architecturally, or not understand subtle critical requirements like weird cases of backwards compatibility that weren't explicitly documented but were crucial.
And that kind of deep, nuanced context is incredibly hard to feed into a language model, isn't it?
Extremely hard. It's what makes those human experts so valuable in the first place. The AI just couldn't replicate that deep contextual understanding.
Those 5 factors paint a really clear picture. And just to be thorough, the study also checked for other potential explanations, didn't they? Things they ruled out.
They did, yeah. They ran a lot of robustness checks. For example, they didn't find strong evidence that the slowdown was just because some developers weren't used to the cursor editor. The effect was similar for users of other IDEs, too.
Okay, so it wasn't just my editor changed. What about learning the AI tools? Maybe they just needed more time.
They looked at that, too. They didn't see a significant improvement or speed up during the first, say, 50 hours of developers using cursor in the study. So it wasn't obviously just a short-term learning curve issue.
Right. And they also ruled out things like developers deliberately underusing the AI, or bias from how tasks were ordered, or if some tasks were dropped.
Yeah, they were pretty comprehensive in trying to isolate the core reasons. It really strengthens the main conclusions about those 5 factors being the likely drivers.
Okay, so let's try to wrap our heads around the big picture here. What MATR really showed us isn't just that AI slowed down these specific experts, which is already a huge finding, but the why behind it. It shines a massive spotlight on that gap between AI potential in the lab and the friction of real-world deployment, especially for complex work and expert users.
Absolutely. It forces a serious reevaluation of that simple AI equals more productivity equation. For you listening, especially if you're an AI researcher or an ML engineer, there are some really profound takeaways here.
What's the first one?
First, benchmark performance isn't the whole story. Not even close sometimes. Those impressive numbers don't always survive contact with messy reality, complex systems, and users who are already highly skilled. That gap is real.
Definitely. And second?
Second, never underestimate human psychology. That over-optimism bias is powerful. People might stick with a tool even if it's not making them faster just because they believe it should be. We need objective, real-world measurement, not just gut feelings or hype.
That's a lesson that applies way beyond just coding tools, isn't it?
For sure. And third, maybe the most actionable point for people building these systems. Context, complexity, and reliability are paramount, especially for experts. Future AI tools need to somehow absorb that tacit knowledge, handle massive code bases more gracefully, and just be way more reliable to actually augment the best developers, not hinder them.
Reducing that cognitive overhead of constantly checking and correcting the AI seems key.
Exactly.
All right, so here's a final thought to leave everyone with, something a bit provocative. While these early 2025 AI systems caused a slowdown here, the paper itself does drop a little hint. It mentions some preliminary evidence suggesting that fully autonomous AI agents, well, they can actually make real progress on core coding tasks, even if they sometimes miss the details, like writing docs or tests.
Interesting. So even if the co-pilot approach slowed things down here, maybe a more hands-off agent approach has potential.
It makes you wonder, right? What does that suggest for the future? If AI continues to improve rapidly, higher reliability, much lower latency, maybe smarter ways to absorb that repository context through advanced prompting or even fine-tuning, could we eventually see that significant speed up, even for these top-tier developers on complex projects?
It's a definite possibility. The pace of change is just so fast. Maybe the current tools are just an awkward intermediate step. It raises huge questions about how we design, train, and deploy the next generation of AI systems.
From slowdown to supercharge, it might be a longer road than many thought, especially for the experts, but the potential is still undeniably there. Definitely something to keep watching closely.